So, I will not talk about the latest cool features of Java, but about more with the experience using Java in an industrial automation project. So, I was not allowed to get a permission of our customer to be displayed as a reference, because I asked the deputy of the deputy in the holidays, but he allowed me to say it's about Royal Mail and their logistics center in Heathrow, UK, in London. That's our customer, and we made a project with him, setting up a mail center, and this story is about migrating this software of the mail center to a new generation and having moved from Borland application server to WebLogic. First, about myself, I studied computer science. I'm a certified senior software architect within Siemens. We have an education program to qualify people, engineers, to become certified senior software architects, where you acquire certain skills and have a certain degree of education internally within Siemens. So my focus is about JEE, service-oriented architecture, business process management, and model-driven software development. One slide about Siemens, my company. I think Siemens is also well known in the field of electrical engineering. It has a 160 years history, can be compared, for example, with General Electric. It's a big organization, and we have several sectors. It's about energy, about healthcare, industry, and I'm in the segment infrastructure logistics, where I'm here placed. And we have several products in the area of airport solutions, postal solutions, that's what I'm talking about. And there we have also reading and coding systems where OCRs of letters are taken and the sorting process is influenced by this OCR. And then I'm located in the department where it's about software of IT, controlling these systems in a sorting center or controlling these systems in an airport center and providing the right information to the right time and making the sorting decisions or manual operations. So my talk will be threefold. I will give an overview of the automation system so you get acquainted to the industrial context where the software solution is all about. And then I focus on the migration project and the issues we have there. And in a summary, I will wrap it up and give you some lessons learned about applying JEE to an industrial context. So the overview. We build up for the customer an international distribution center. As I mentioned, Royal Mail. There, our general contractor supplied the whole building, the material handling systems, the sorting systems, all the IT infrastructure, and we, as a subcontractor, provided the production control system, which controls everything in this area. So you can also see it like a manufacturer execution system. It's not the primary control systems of the material handling and the low-level stuff, but the high-level production control system which controls all this stuff. So the software which controls the sorting center on a logical level, it provides IT support for operational processes and realizes the planning, monitoring, and reporting of this plant. So the goal of our customer was to merge the different international exchange centers, which were all over Great Britain, to one place close to where the mail flows out of the country and comes into the country. That's at Heathrow Airport. And by doing this, we wanted to increase also the degree of automation, because all these different international mail centers, small centers, have limited capabilities in automation, thereby decreasing also the level of redundancy, because you have several things in different places, connection to EDI systems and so on, to merge this in one place, to have ease of control of the whole management of the mail operations, increase the overall efficiency, and also increase the quality of the international mail operations, because there is also an exchange of money between the countries in the international level. For example, if you have the postage is paid in a country where the mail is originated, but the revenue has to be shared between the countries which take place in the whole logistic delivery chain. So you have to really take track of the amount of mail volume coming from the other countries and make a correct calculation and getting your revenues out of it. Also, for example, if you have international mail and need track and trace capabilities, you need to do this in a central place. So I will give you an overview of this system in a logical way. So such an international distribution center has two modes, at least at our customer. There's one mode, the export mode, where the mail flows out of the country. You can see trucks arriving on the right-hand side with the mail from the different mail centers. The mail is put and processed in the arrivals area. There the bags and sacks are opened and put on material handling systems and directed to the right places in the center, where you have different manual and automated sorting machines. Then the mail is sorted, collected after these sorting stations, and then moved to the dispatch area, where the build-ups are done for international flight. This is typically flight. So you have this aluminium airmail units where all the stuff is packed into, and then it goes on different lorries which go directly to the airports and to the loading areas there. That's one direction. The other direction, the lorries from the airport would come in with their ULDs. They will be broken down, sorted to the country, to the final destinations in the country, and then on the dispatch area, collected to different transports to the different parts of the country. So that's in principle the way such an international mail center works. So we have two modes. And for example, it's now the work of the PCS to schedule this. When do we have import time? When we do have export time? Which resources are allocated? What are the places where the trucks are built up, where the ULDs are loaded, and so on? The rostering of the stuff. And this is all done in the PCS software. So something to the history. The project started in 2000, so that's quite a long time ago. There was a general contractor. It was Dematic Rapistan in US, in Michigan. And my part of Siemens was a subcontractor which was responsible of building the software system. Then Siemens took over Dematic, so Siemens was suddenly in a position of a general contractor at the end. The go live was planned for 2003. Things did not work this way of many reasons, because it's a real large project. We had finally the cross-dock operations in 2003 and the final operations in between 2005 and 2006. So as I mentioned, it's a highly automated mail processing facility, and at least at that time it was the biggest international postal logistics center of the world. There are different mail categories. We have the letters, we have the flats, and we have the packets. And for all these different streams, you have different material handling and sorting systems. For the letters, for the mail, you have a high diversity of different mail streams with different service level agreements, I would say. You have the inscribed mail. You have in UK you have a large variety of mail services which you can have different stampage and labels put upon, and the software has to take into account this rich diversity of mail streams. And during the project, even more mail streams were added, so we come up to this final 47 number of mail streams. So we have a high-performance distribution logic, and the quality of service is in focus because it's in the international spotlight, where it's very critical. If this fails, if there is an outage, the whole mail will be stuck into this mail center and will be of great interest also in the press. So it's a business critical. We have there are, as you can imagine, there are only few hours in a day where you might apply a patch or might exchange the software. So in principle, it's 24 hours, 7-day operation, because there is nearly no stop in flights going in and out. And if there's a stop in flights, you can still prepare for the early morning mail. So for us, it was a challenge because it was a very large project. There is 3-shift staff in a 40,000 square meters building. We have about 200 to 300 people per shift, and these people need the IT support. We have about 9 million of items per day, which are processed by this center, and we have 750 road transport, 250 flights. So we have 130 ULD loading devices for these large aluminum containers where you load the freight to the aircraft. We have nearly 2,000 roll containers, 50,000 bags, and so on. And we have many interfaces to the external world. As you can imagine, for example, EDI interfaces where you get pre-announcements from other countries for that on this flight a certain amount of mail arrives, so you know what comes up to you, so you can decide and plan in advance what you're going to do. So about the material handling automation equipment, it's really impressive. I have only 3 photos which give you a slight impression about how this site looks like. 7 induction lines, 12 kilometers of conveying systems, 2 really large tilt tray sorters which go through the whole building. It's like a chameleon connecting everything. 10 letter sorting machines, 3 flat sorting machines, crossbelt sorters, loading robots, automated guided vehicles which go through the plant. Security screening systems, of course. You can imagine if things go out of the country, you have to inspect all the stuff which goes into the plane. You have to X-ray that, all the things which go out in the aircraft. So in fact, all mail which goes out of this mail center has to be inspected by the X-ray machines, and the system has to guarantee that this also happens. It's a security critical thing at that point. So we have 67 different workplaces to support with our clients. There are 257 PC clients with barcode scanners where someone is scanning a sack, and I have an example for a screen of this workplace. We have handheld terminals which have also dialogues on it, which effectively are the same as PC clients but using a handheld device, which was not so common at that times. Today it's much more typical that you do this. We have document and label printers. We have scales where, for example, for revenue protection purposes, where you want to ensure that the amount of mail that you get is from a big mass mail center. Yeah? You have to verify, or postal organizations want to verify, if the mail is really of the amount which is indicated by the mass mailer. So what you do typically, you weight this, and then you compare and make statistics and say, is this in the range of what is allowed for about 100,000 mail pieces? So this is also one function the system makes. It makes sure that the revenue of our customer is really protected and that he gets his revenue. So this is driven by a server farm with, at that moment, 23 high-performance servers and about 2 terabytes of disk storage, which is now nothing. It was in 2003. It was really it was a challenge for us, at least for us. Today it's nothing. It's factor 10 or 20 higher or even more. So we have 72 business logic components here and 23 interfaces and communication services which we have to implement. So that's just an overview of the functionality which we have in this stuff. So we have a production planning and control system. We have to make personal planning, machine planning, production and process monitoring. We have cross-functionality, for example, containers which flow in this material handling system have to be tracked. We have to identify, we have to control the material handling system, which is a subsystem, which is a very important subsystem, for example, which has to take care that every export mail is going to an X-ray station. We have a dock and yard management system for the truck arriving and departing. We have communication system, for example, for the UPU and all other customer legacy systems. We have arrival and dispatch monitoring and control. So you have to have a workstation which identifies the mail which is in the sacks which arrive. You have to make up you have to control the sorting. Sorting management is very important because you have to load the right sort plans to the machines at the right time. Mail sorting machine takes the mail items, looks at the identification, the address, and decides in which outlet to be sorted. And in order that the system is able to do this, it has to have a sort plan, which it's a lookup table which says which ID goes to which direction. And this is very important that the right sort plans are at the right machine at the right time. And this is part of this planning process. Then we have special services, like I already mentioned, the revenue protection, for example, mass mail, weight the mail from a mass mailer and verify if it's in the contract limits. You have document handling. You have many documents which come with this mail and documents which have to be generated for sending the mail out. You have to have waybills, and there, for example, if insurance items you have to list all these items in a bill of lading. You have to, for example, aviation security support. This is taking care of the X-ray machines and taking care of that everything is going to the right X-ray machine. We have a process optimization. So we take all these figures out of the process and make reports. So for next period of time, when it goes to planning, you have the right figures and know how to make the plans for the next quarter. So it's very important to take all these production figures to have the right figures for predictive planning for the future. So just some slides, impressions. This is the big sorter, which I hope I have the right. This is a big sorter which goes over the place. Here you see the Elmer units, this aluminium stuff which is loaded. And here you see some manual working places here. Here the sacks arrive, here the trays arrive, and they are merged into the sacks. And here we have a workplace which some support from the production control system, which gives you instructions to place it in which sack and to scan it the right way and so on. So there's a picture. So this picture gives a last functional overview. We have the planning system. Yeah, planning system which plans in advance and then instantiates the current day. And we have here this different, cannot see it, the personal management, the material handling, the sort handling, dispatch management, and so on, is controlled by this current day and the plans for the next days. And then the data which is generated during execution of the process is fed back to the monitoring system and displayed at the supervisor, so he knows from today and can now derive his planning for tomorrow and the next periods. So now let's focus a little bit more on IT. Maybe you have now got a little background about the system, what's it all about, what the functionality is. So we have this production control system sitting on top with its clients and the external information systems connected to them. See here? And we have on the bottom line this whole material handling, tray handling, and control equipment. And in between, we have the letter sorting machines, the flat sorting machines, staging equipment, and packet sorting. And for every such subsystem, we have an area concentrator, which is acting as a proxy and controlling the operation of the subordinate system. For example, the subordinate systems may be implemented using WinCC or Wonderware or whatever you have as a control level platform. And then in between there are the area concentrators which do the interfacing to the production control system. That's one principal way the system is built. So some screens, just to give you an impression, it's boring swing applications from today point of view. It would be nice to renovate this, maybe using JavaFX or another nice GUI technology. It's all rich clients. There are no web clients at that time. I have some figures here, and this is, for example, this operator UIs. It's more for touch displays with big fonts because people which operating there have gloves in their hand, and they will scan a label and they will get instructions what to do. For example, place a sec on this line or on that line. So alternative to this UI are handheld devices, of course. So coming to the system architecture of the PCS. The software is based on formerly J2EE, now JEE. And I think it was one of the first adoptions of JEE in an industrial context. The architecture was laid in 2001. And we choose JEE before we use Corba and hand-coded pieces of software, process here, process there. We wanted to integrate this and ensure that we can scale up with the number of clients, which was impressive for us at that time. For example, 500 to 600 rich clients with an unknown, for us, not so really calculatable load on the system. So we said we have to use an architecture which can scale and scale up with the increasing customer demands. At that time, we used a Borland application server with EGB 1.3. Now we are at 6 or 3, EGB 3, which was migrated to WebLogic. We have JMS. We used Sonic MQ. We also moved it to WebLogic, where the Corba, Borland VisiBroker Corba communication is still in fact as a link to area concentrators. We replaced this with JDK Corba. We have business intelligence for this reporting, for this taking all this data out of the system with SAP BO. It was customer's choice to have this tool in place. We have an Oracle DB. We started with 9i in the failsafe mode and moved this to 10G in a real application cluster with first 2 and then 3 nodes. This was not part of this migration project. This was already in a scaling phase. After the initial deployment, it was scaled up to 3 nodes because the customer bought, I think, about 100 additional handheld devices, which increased the load. So we added application servers and we added a separate rack node to it. And we have a storage area network, I think fiber channel at the time, with an online backup. And HP server hardware. And for the handheld devices, there is a JBoss application server which is serving the Epic Data Expresso server. This is something you get bundled. It comes with Simple. At that time, the dispatcher was this Epic Data Expresso server, which has a JBoss inside. We started with JDK 1.3, and in part of the migration project, we moved to JDK 6. So this was, we have here the application server farm. This is Espresso clusters. Here, this is a PCS on 5 nodes finally. Then different additional clusters for special things like for the area concentrators. We have the database and the backup system, and this is a separate cluster for forecasting. So here you see this is now WebLogic, and here the Oracle Real Application Cluster making an online backup using DataGuard on separate machine. And here we have also Oracle and SAP Business Objects for the business analytics, which is separate. So the business analytics is not going directly on the operational database, but the data is also replicated to this special BI database, and then SAP BO accesses this database. So then we have here one picture which shows the connection to the outside world. We have the mail center. We have the airmail units where you have you have also additional clients for the PCS here in Heathrow and in Gatwick, where you can do special things. When late mail arrives, it will not go to here, but it will directly go to the airmail units. You can also enter additional mail to some airmail unit device. So you can, if something goes, if you're too late, you directly go to the airmail unit and put the mail there on the plane. Now the customer has also outhouses. When there is peak operation, maybe before Christmas, he rents, or he has now additional buildings which he calls outhouses, where he makes a temporary installation of PCs. Typically you have here, and makes additional build-up and sorting in this area to expand his capabilities for a temporary time. And he has many legacy systems which have to be connected for the EDI system and internal systems of the customer, which you have to interface. So now we come to the migration project overview, the core of my talk. So the goal was to extend the lifetime and the maintainability of the system. So the system was in operation for nearly 8 years, and the customer had to do something in order to keep his system in a good shape. So he had to make the server hardware upgrade because the server were out of guarantee. He also has to make a software upgrade, an operating software system upgrade. He wanted to introduce database replication in the database, as I mentioned, with a HA, high availability solution, data guard solution. There were also some other overhauls of the cargo control system. The start of the project was 2009 in August, and we successfully got our acceptance in April. So this project was half a year or a little bit more. And now we have raised the level of the software to a new level where we can keep ongoing maintenance, which is a very good revenue for us. It's also for the customer a very good thing. And he will get upgrades in our software in a regular basis. And we have a very successful maintenance phase now with him. Oops. So what did we do? We upgraded from old Borland application server, which is now no longer existent, to a WebLogic application server, to 10.3.4 now. We have to migrate up to Java 6 because all our software was now on Java 6, and 1.4 was no longer part of our software. We had an internal component framework we call BC Bundle. We have to upgrade it also. So he gets a really new upgrade of the whole stuff. We had an iLog JView charts replacement with JFreeChart because we no longer need it, and it was quite expensive for maintenance. And we did upgrade iLog Cplex. The Cplex is used in the forecasting part, where you take the actual data and trying to make a forecast if you reach your plans for today, if all the deadlines are met and schedules. And of course, also we upgraded to Oracle 10G from 9.1. The maintenance project now is already looking at 11G to upgrade. I think maybe next year we will upgrade to this version. As you also can see, we are in a business where the customer is very conservative, and we have to provide long-time maintenance, which is not so easy if you're using today's frameworks, because you get updates every half a year or even more, and it's very difficult to choose the right point. To take the right version of a WebLogic, to take the right version and patch set of an Oracle database. This is very, very difficult, and we often see that the open source and also commercial off-the-shelf vendors are not aware of using this in an industrial context where you cannot upgrade just every half a year. Yeah? Our customer will tell us, "Are you crazy? Yeah? We are not allowed to go there and upgrade." And this is really never change a running system here. The customer will kill you if you just upgrade every second month. So this is also something which is very important for us to really know from Oracle the roadmap and know which versions are in a final terminal release phase where you can now trust and say, okay, I will get another maintenance for 5 years to have a successful maintenance business. Oops, wrong direction. So I will go to the details. So we have a JDK upgrade from 1.3 to 6, which frightened a little bit because you have to imagine this big system with all its software. After going live means it has to work. It will not be allowed that something crashes we are not really able to test this at our homes. We can only test certain aspects with simulators, but in fact you cannot test the whole plan. It's a real difficult thing. So JDK upgrade was quite easy. We had some small issues in Swing. There were some changes, but we get a really significant performance gain. This was really interesting. XML technology, there were some small upgrades from JAX-P, which did not really bother. With JDBC, there was a little problem with a big decimal, changed a little behavior, mapping to the database, I think. Nothing spectacular. Then we encountered a problem which we really did not expect in our plan. We have this Epic Data server which connects these handheld devices, and after 5-6 years, it was outphased. So we could either replace it with complete new technology, or see how we can to get this interoperable again. Because the customer did not want to change his 400 handheld devices. They are there. He has no money for just replacing them to a new version. So we can only upgrade it to JDK 1.4, and then we have this JDK 6 and JDK 1.3 interoperability with RMI IOP. We did not expect that. It did not work. So I think we spent one person month in investigating this problem, looking how to do it, and also we discovered if we're using RMI IOP only gives us interoperability, but there is no failover. So then we discovered that WebLogic supplies the right client library, which does this just for us, and we did not know about that. So if you have to do this problem, take a professional consultant which has more knowledge in this area. At that point we were ignorant about the problem. We thought we could save money, not asking one, and the person was trying too long on his own. Yeah. So this is good that old libraries, WebLogic provides libraries with interoperability to newer versions. So this is very good. So then we upgraded from Borland to WebLogic. There we had to know about that. It's about installation, it's about clustering, it's about data sources, it's about JMS and EGB configuration. So that's a problem field where I will provide some more details. So the preparation is get training for administrators and architects, know about the new product, get initial consulting, so you know what you're doing. This is very important, and we did this, of course, but not in every place. So configuration issues, yeah, it's about XA, data sources and drivers, what is the right data source to use, normal data source, multi-data source, because we have a real application cluster. There are also contradictions in advices from experts from Oracle and experts from outside, which we hired. So we're using normal data sources without RAC, because a real application cluster, because we don't want load balancing. We're using the real application cluster, in fact, just for fast failover. So we, in fact, in fact, did not really use the load balancing for the 3-cluster real application cluster. It's a little bit out of order with this with this decision to just use real application cluster for fast failover. So you have to test failover on the level of the database. It's really important to have all the right nuts and bolts, the correct settings, so that it really works. So today, WebLogic 10.3.4 introduced grid-link data source, but we were not aware of that because we started with 10.3.0. So I think today, grid-link data source would be the right thing to use for the real application cluster. So EGBs, you have to migrate the deployment descriptors and configure them for fast failover. We have 74 jars, nearly 300 stateless session beans. We had to do no changes. We have also container managed beans. We made an automatic scripting which changes the deployment descriptors. We have also some legacy container managed beans, bean managed persistence beans. We had to eliminate them at that point. So sometimes we got, in importing the whole stuff, we got sometimes poor and cryptic error messages from the EGB compiler, which really puzzled us and took a long time to find out. There were some errors in the deployment descriptors, which worked just for the Borland application server. It was ignored, and we had to change this for the more strict WebLogic EGB compiler. So we considered also migrating from EGB 1.1, the CMP, to 2.1, but this was difficult because Borland already supported optimistic locking in the EGB 1.1, and WebLogic requires EGB 2.1 for such a feature. So we stayed with EGB 1.1, which is still supported, and are now using pessimistic locking, which worked. It was too much, changing so much code for this migration project only. So JMS, Borland was bundled with Sonic MQ, where you have a single broker instance, which was made highly available. So every traffic JMS messages go to this broker and then go back to the cluster. And we're using a Windows cluster with a shared storage to make the persistent queues and topics. There is also, Sonic comes with a more advanced high availability feature, but we did not use that. So we have an out-of-process JMS broker, and it requires 2 network hops in such a configuration, where WebLogic typically comes with an in-application server broker, which saves you 1 network hop, but also gives you other issues because it's a little bit different. So Sonic also came with advanced features like server-side filters and shared subscriptions, which we did not have at the time of the migration. So this is now, WebLogic also supports that. So the architecture of JMS, the architecture of now with WebLogic is much more different than Sonic MQ. I'm not sure if you are aware about the architecture. You have a large number of possible deployment scenarios. You can have the brokers with your EGBs. You can have a separate cluster of WebLogic application servers with JMS only inside. So you have really to make up your minds, and you have also to select the correct database driver. And the JMS destinations may be distributed. This is something which you need to use if you have a cluster where external systems like our material handling system can send messages to the whole cluster. So anyone has to receive it. Any one of your EGBs has to receive it and service it. So in 10.3.4, new features were added to WebLogic JMS, which now has the same level of features which you have with Sonic. Yeah? So you can define 1 consumer per clustered application, and this is what you want, what you need. Yeah? You get a message from outside, from your material handling system, and one instance has to take care of this message. Yeah? just one for your whole PCS application. Yeah? You do not want that in every application server this message will be processed, which they have several options to do that. But this is typically the right logical solution, that you have one consumer per application per year. And this was not possible at the time when we migrated, so we had to make a little workaround. But today this would be the right thing to do, the right configuration. But you have a lot of different. It's quite difficult to configure WebLogic JMS to what you really need. You have many points where you can adjust. So I just explained to that. It's also, if you have in-process JMS, it's very efficient. Yeah, you have one EGB sends a message to the other one, and typically it will be consumed in process. Yeah? So you have no network hop. This is very efficient. However, you can also configure that it goes to another node in the cluster, which may be also okay. If one message generates a lot of work and traffic, maybe it's good to distribute this to another node. So you can configure this, but it's really difficult. You really have to look at all the details how to configure WebLogic JMS to make the right choice. You have many nuts and bolts to configure. So as I mentioned, you can stuck to your local server. Yeah, then it's very efficient, but it will generate additional load. Or you can balance in a cluster, which is good for load distribution, but it gives more latency because of the additional network hop. So the distributed queues or topics are very good if you have just a pure EGB solution where you have no external processes. Yeah? You have messages which are generated inside your EGB applications and go to other nodes, and this is very good. There is no problem. But if you have outside processes which generate messages and inject messages into the system and consume also messages from the system, this is difficult, because maybe the external system sends a message to one node and the consumer is not there, it's connected to a different node in this cluster. And this typically the situation will not occur, because connecting to the cluster, which has no consumers, will direct you to another node where there is a consumer. Huh? But during failover, a situation can occur where you have a sender going to a node which has no consumer, and there is a consumer where there is no sender. And for this problem, you can configure queue forwarding, which solves the issue. But so a message is sent to one node, there is no consumer, and then it's forwarded to one of these nodes where there is a consumer. But this is something ugly. You have to configure a forwarding of messages, which is really not what you want. I have a picture for this, and this can happen if you have external producers and consumers, like we have with our material handling systems, which are not inside the application server. So you have, for example, a material handling system or a sorting machine which generates a JMS message, and there is no consumer because there is no message-driven bean inside this application server. But you have here an external consumer, and this situation normally is prevented by proper connecting, but it can occur if there is some failover situation. We have discovered that this will happen, that it will be separated, and then you need queue forwarding, which forwards messages from queues without consumers to others. Yeah? But this is not really ideal. So with the distributed topics, I already mentioned that. I will skip over. I discussed the point how many MDBs are invoked. One per configured MDB, or one per server, or one per application. And I described you that one per application is typically shared subscriptions, that's what you typically want to have in your application. So there are many nuts and bolts to configure, and to get the latest performance and the real high availability, you have to study a lot. It was with Sonic, it was much simpler because of this quite primitive out-of-process broker, which did not give you these choices. So it really requires a careful testing to ensure maximum availability, and you have to look at this very carefully. Now, we've seen from WebLogic 10.3.0 to 10.3.4, many important features have been added. And at the end, everything is there what you need. So now, if you are now going to use WebLogic for JMS, I think you have every choice you need. But there is still room of improvement because you have so many nuts and bolts, and the default configurations are never what you really need for your high availability industrial solution. So the defaults are only connect in this situation or reconnect in that situation. So what I really wanted to have is that get a out of the box system which is really high available. And if you want to have more performance, maybe then you can tune. So testing was a important thing, and in such a big industrial solution, the porting from JDK 1.4 to 6 and from Borland to WebLogic, you can do it. It requires our estimation is the pure porting is maybe about 25 weeks of work labor, but testing is essential because you're really throwing away all the plumbing. You change completely your whole system. You have to test and test and test. And we, at that time, it was before. This is a real cloud, a hardware cloud, where we have really installed all the clients to make real client load with hardware at that time. Today you would do it differently, but this was testing before the virtual machines and crowds became so popular. So we got some issues after acceptance. We had some problems with the T3 buffer size. You have to really look at that. This is a low-level buffering when WebLogic exchanges data over T3 protocol with the clients or within each other. When you, for example, make this queue forwarding, messages are forwarded from one to the other, and there is some inconsistency. So, and we had a problem in cluster starting. This was all something we did not really think that this will happen. If a cluster is started and the full load is already on it, all clients connected and trying to start up, we got some hanging. There was servers talk to each other and was not really, there was no progress in starting up. So we erased this issue and we got a patch, and finally this worked, and it was incorporated into the WebLogic mainstream. Oops. So to sum up, what were the architectural drivers for using JEE? So in such a logistic environment, we have a network-wide distributed system. We have many PCs, we have many area concentrators, all connected. We have a high volume of data, because all this production data which is generated then finally goes into the BI database. Collecting this production data is very important for us and is a part of our product. But we also need an online reaction at the PCs of the operators. So it's not a real-time thing, but online. There is someone waiting for the answer, and if he doesn't get the answer, no work progress is done. It's not critical, nothing goes out of the window or crashes, but the work will not be carried out. So in rare cases, if something hangs for 10 seconds, okay, it's annoying, but this should not occur many times. And we have a long lifetime of the system. This is very important. So, and we choose JEE for that. We want portability, we want operating system and vendor independence, and we needed that in this migration project. It was really critical that we could port it to another application server. This was really critical. So, and for the non-functional requirements we have in this area, it's about availability, scalability, we use both, and also performance. What we did not really need here is security. It's inside a plant, there's no connection to the internet. At that time, it was okay, there were no firewalls, it was just not connected. But transactions are also very important, because you can imagine if some message is generated, we make many, many updates in the PCS database. And when one of the instances fails, the transaction is just not committed. So that's something to keep the system healthy, is transaction-based processing here and being able to fail over. And we do this all the time. If we, for example, upgrade software, we upgrade it, we shut one server down, we upgrade, we restart it, and it works every day. So it's really, also our system has some problems maybe sometimes, small memory glitches or whatever, there's no problem. You restart the server and operation fails over to the rest, and it really works. And typically the operator will not see anything, and the database is not corrupted because of this transactional integrity. So what we can say as a rule of thumb, if we have today typically 2 application servers and 2 DB servers, that's just for high availability, because the PCs in this are so powerful now. We do not need the scalability in having too many boxes. But we can manage with such a configuration. We have 100 messages per second, and we have in these messages about 400 events which we can incorporate, and we have about 2 gigabytes input per hour in our database. And this is easily managed by the system. So portability, yes, we can port it to many operating systems. Migration to new JDKs is really rewarding. And this is using standards. This is very important in this business we are in. And JEE as a portable component framework has really proven its maturity. You have a large number of commercial off-the-shelf and open source products which you can apply. And the migration of such a large application is possible in a reasonable time frame. So scalability, yes, we did this with adding more boxes, but got less important because of the high-performant hardware. So now it's more that we, on a single box, we add more instances to make use of multi-core technology. As I said, the overall availability, it's really part of our daily life of maintenance, restart of servers, rolling software upgrade, no impact on the operation. That's really one thing. If you design your EGB methods, for example, idempotent, stateless, as is also with the REST idea in mind, you have no problem in switching a server, killing a server. This really is a very robust system where no problems occur. And performance, it's at the time being deployed, we had about, I think, 60% CPU at maximum. Now it's below 20% with new hardware, with better middleware. Extensibility, we have 500 changes over 6 years, and the team size was 100 people at the beginning. Now we are about 10 people in maintenance. So I think also the architecture is an enabler for long-term support, to be able to identify the business components, the coarse-grained business components in EGBs, have defined service interfaces, really helps you in having a system which can be maintained over such a long time. So we have identified areas of improvement. JMS requires more standardized features. Maybe this comes with JMS 2. I have no idea. I think they are just eliminated boilerplate code. So what I really want as a user of JMS, I really would like to see high availability features in the standard. Notions like distributed topics or these things which you need in practice. Singletons are also sometimes necessary and should be standardized. We see that in sometimes clustering and administration remains proprietary. I hope that this will be fixed when you move to the cloud, which requires these standardizations here. So for us also a little bit the roadmap of WebLogic was unclear, and it's very important that you know the roadmaps of your middleware if you make the decisions for such a long time, for such projects which will be in operation for 10 years. You really need to know what is a major release, what is you can grab and you get long-time support. So this is very important. You really have to think about projects which have a lifetime with 10 or more years. You have to need to know the roadmaps, and you have a vendor which supports you for that time. So we did this project in England successfully, but now we are standing before a similar project in Switzerland, where we have also a postal environment with a network of distribution centers, all still using Borland application server, and we got the project to migrate this to WebLogic in the next year. So there we have 3 mail centers and 6 sub-centers in a nationwide implementation where we have to roll this out and migrate the whole stuff to WebLogic. And also we will introduce Oracle Service Bus for interconnecting this. Okay, that was my story about migrating to WebLogic. Have any questions?
How will you synchronize software updates to the old system with the new system, since it took a year to implement the migration?
So there was a point in time where we had to migrate, and it was identified with a customer. There was some fixed date where maybe it was a weekend, identified weekend, where I don't know how this was managed. Maybe there was a scheduled outage. I don't know. But it was a appointed date, so the operation the plant was shut down for that. But it was identified with a customer, and it had to work. Yeah. I think it was done at night, at the time where the flights are a little bit restricted, with a small time slot where we could do this. But it was appointed with a customer, and he really had to make long-term planning to allow this point in time. So there was a fixed date which was not movable. Yeah. Because such migration was not possible within just rolling upgrades, as you can imagine. Yeah. And it ran successfully. Got some issues after some time as the system grew a little bit old. We had to tune and tweak a little bit and make some patches, but in principle, it was done in one migration step. Okay, thank you very much.